Hi, in this video I'm going to show you how to build a Linux kernel. Building a Linux kernel is a little bit more complicated than building another program because you need to expose the bootloader on your computer. Exposing the bootloader allows you to pick the kernel that you're going to boot on your computer so that if the kernel that you're building doesn't work properly, you can always go back to the kernel you're running now. The two kernels won't interfere with each other. Also, you are going to have to install a bit of extra software on your computer in order for the Linux kernel to build. We're going to do all of that right away. Okay, I'm going to install software with apt, but you can use snap, dpkg, yum, or any other package manager with similar file names. I'm going to use apt-get, and the software you're going to need is build essential, kernel package, libncurses5-dev, fakeroot, wget, bzip2, libssl-dev, and libelf-dev. And you should get all of these packages before you try and install the kernel. I've got exactly what you need right on the screen. Okay, before we begin, one note. I'm going to edit system flat text files with VI. I strongly recommend that you use a flat text editor like VI, and strongly recommend that you don't use something like a word processor. The reason for this is that a word processor will add hundreds of extra characters to the file for formatting and making the fonts look pretty, but your system doesn't know anything about that. It will then try and interpret those fancy characters, and it will fail at that, and your system files will be broken. So don't do it. A test is to create a file with some text in your word processor, save it, and then try and use the cat command to print out the file on a terminal. And if it displays anything other than what you typed, you have a problem. I will use VI. VI is a common text editor on Linux systems. If you are stuck on a Windows system, use Notepad and save text as a flat file. Okay, so the next job we need to do is expose the bootloader on your system. On a Linux system, the bootloader is an automatic thing. It's just that you might not see it because some distributions don't expose it. There might be a chance that the first kernel you build won't work okay, and you might want to go back to safety, or at least the first kernel that you started with. And so if you want to go back to that kernel, you need to be able to see the bootloader so you can pick that one as opposed to the default, which would be the latest kernel that you built. And in order to expose the bootloader, and the bootloader appears right after the BIOS screen when you're starting up the computer, but before the operating system. And it appears for a certain length of time, which you can adjust in the configuration file. And you adjust the configuration file by running from a terminal sudo space vi/etc default grub, just like this. And you see the configuration file. The first line that you might want to change is the default. When you see your bootloader, the last kernel that you built will always be the default, and it'll always appear at the top. And now if you set the default to 0, it will boot the last one, and it's the one at the top. If you change this to something else, say you're finished building kernels for a while, and the latest one, the nice one, the one you started with, the safe one, is say the third one on the list, you'll want to change this to 2 because it's always off by 1. So the third one down will be number 2. The next line that you might want to change, and it might look like this. It might be not commented out. Timeout style equals hidden, and you don't want the bootloader to be hidden, so you comment it out like this. And the next line that you might want to change is timeout equals 5. If when after the BIOS shows up and the bootloader shows up, and the bootloader will appear for 5 seconds based on this line. If you do nothing at all, if you don't touch any keys, it'll go back and boot the default kernel that you have set here. You can change the number of seconds, so if you want a little more time, you can change this to 5 or 10 or 15, whatever you want. It doesn't have to be increments of 5 either. So just pick whatever you want. I set mine to 5. It's a nice number. The next line that you might want to change, and it might be commented out like that, and you don't want it commented out, is the quiet splash line. And this also lets your bootloader show up nicely. When you've done all of these changes, make sure that this one is commented out and these other ones aren't. What you want to do is save this file like this, and then what you want to do is run sudo update -grub. When you run this, what will happen is the changes that you've made to /etc/default grub will be reflected in /boot in your boot directory. And when you run it, it'll show that it'll show you all of the kernel images that you've got currently available, just like this. And what you can do now is type uname-a, and it'll show you the current kernel that you're running right now. It's Linux, the machine that it was built on when you compiled the last kernel. If it was somebody else who compiled the kernel, it was maybe a kernel that you got from a distribution. This will be different. That's the kernel name, the version of it that was that kernel is that you're running right now, and then it'll give you the date when that kernel was built. And what you can do now is reboot your system. And you can check to see if you've got a bootloader that's popping up. And that's the next thing to do. Okay, so the next step is getting the Linux kernel software. You can get snapshots of the Linux kernel from different sources, but I'm going to get it from GitHub with a script. Unless you have extremely modern hardware that has only been added to the kernel, most of the kernel will be well-established code that has been in the kernel for possibly years. You might be a bit nervous if it's a release candidate 1 version of the kernel, but anything else will likely be very stable. The kernel developers don't recommend using any release candidate kernels for production environments, but for testing you will have no problems. In more than 20 years, I've only ever had 1 or 2 serious problems with an RC1 kernel. I've had a few minor problems with release candidate kernels beyond the first release, but that usually involves hibernating the kernel. So I'm going to show you a script for getting the kernel from GitHub. Okay, I have a script that I use or can use to get the Linux kernel in a directory. I'm going to show it to you. And here it is. And what you can see is I start off by setting a variable called srcdir to kerneltree.get. Kerneltree.get is going to be a directory that holds the Linux kernel in the current directory that I have. The next line is if that directory doesn't exist, then I run git clone, and I clone from this website. git://get.kernel.org/pub/sem/linux/kernel/git/torvald/linux.git, and I clone it into my source directory srcdir, and then I change to that directory. And if that directory does exist, it skips over to the else side of this and goes to source directory, and then it runs a git pull. Git pull will just get all of the current changes that have occurred in the last tag since the last time I ran git pull or git clone. So this will just pull in the updates. Git clone will pull in a whole lot of software. It'll be hundreds of megabytes, and the first time you run this, if you haven't got an archive, it will be hundreds of megabytes. The next time you run it, you run git pull, and it won't take very long, and it'll only be maybe 20 or 30 megabytes, or maybe a little more than that. It'll be much less anyway. And I'm going to run all of this right away. Okay, for demonstration, I'm going to get rid of the old kernel source directory. Normally you would keep the old archive, but just for demonstration's sake. And now I'm going to set my source directory and get the new archive. This may take a bit of time. I'm going to go for coffee. So now we have the kernel archive. It created this directory called kerneltree.git. Right here. And it has all of the source code. Okay, so that's the last part of getting the kernel, and we will now go on to configuring the kernel for your system. Okay, so configuring the kernel with menuconfig is what will take the most amount of your time. There are a few things you need to know that can make it a bit more reasonable. Instead of doing this every single time, you can save any changes you make to a local file and then also save those changes to a file called .config. .config is what the kernel is actually being built from. So if you at first save your configuration to mykernel2024, what you want to do next is save it also to .config. If you have fully configured your system and have saved all of the changes to your liking to mykernel2024, and a new kernel comes along, and new ones come out every week except for the first week after a stable release, all you need to do is load up mykernel2024 and save it to .config. Another tip is that if you are descending through menu after menu in menuconfig, and when you leave submenu after submenu and forget or don't realize that you are in the main menu, and suddenly it starts to build the kernel and you haven't saved your last set of changes, don't worry. Before it starts building, if you have changed anything at all, it will save all of your latest changes to .config. So then all you have to do is copy .config to mykernel2024, and it will also be up to date. Another thing you need to know about make menuconfig is that you will be given options to have loadable kernel modules, which are drivers, either built in or created as a loadable module which is separate from the kernel image. Normally it's best to have as much as you can loadable. So for example, if you're compiling in support for a floppy drive, you probably won't want it built in because you won't likely need it all that often. So it would probably be best to compile it as a module. Also, please remember that wherever your kernel modules are stored, and it's likely a hard drive, please compile support to access that device as built-in and not as a module. Now the choice is yours whether to try and configure a lot and possibly have modules you don't need, or only configure the minimum modules you need and potentially have hardware that isn't immediately supported. You can always go back and add support in another kernel build, but that's at the expense of having to build another kernel. At this point, the choice is yours. Now, assuming that you are still wondering about the hardware on your computer, the first command you should try is inxi. From a terminal, just type inxi-FXZ, like that, and you can pipe it to less. Right now I'm just going to pipe it to head-4 just to get the first 4 lines. And it gives you all kinds of information about your system. If you don't have inxi or want a lot more information, there are commands that start with ls that can help you. Just type from a terminal ls and then hit tab twice, and it will give you a list. For a general overview about memory and your processor, use lshw. For specific PCI devices, use lspci. For USB devices, use lsusb. For hard drives, which are referred to as block devices, use lsblk. And you can select on one of them and then type sudo hdparm-gi/dev and then the device, and it will give you all kinds of information about that device. Another big hint is to type lsmod or lsmod This shows you which modules are in use right now. Certainly if the kernel you're running now is using them, then they are useful and you should make sure that they are all included. But keep in mind that if the kernel you're building is a lot newer than the kernel you're running, the names of the modules might have changed. One last thing before I show you a kernel build, the .config or configuration file is just a flat file. They look like this, and you can edit them with any flat file editor such as VI, although it's usually easier just to use menuconfig. Make sure you keep the format and layout as it currently exists, but you can search it for specific devices, and that might help you configure your system. When you see a variable commented out and it says is not set, that variable isn't being used to build the kernel. When you see a variable uncommented and at the right hand side it says equals y, that means that variable and the option it represents is being built into the kernel. That's a built-in. When you see a variable uncommented and it shows equals m, it means that variable and the module it represents will be built as a loadable module. Okay, so before building a kernel, I'm going to show you menuconfig on its own. This will run automatically when you run the script, but I'm just going to run it on its own for now. So first I'm going to change to my directory, user source Linux, and then I'm going to run sudo make menuconfig. And this is what it looks like. Options with an arrow on the right can be selected by pressing return. And up and down arrow keys will let you scroll through the options. When you're on an option like this, you can select one of them by pressing space. Sometimes they have other things that you need to type in, but certainly here you can press space and press space again to select something or unselect something. Sometimes when you get another arrow key like this, you can hit again return to go into another submenu. To return from a submenu, you press exit. And when you press exit and you finally exit the last menu, again with return, it'll ask you, do you wish to save your new configuration? You can either select yes or no. If you select yes, it will save all of your changes to .config. If you select no, it will just tell you your configuration changes were not saved. Okay, so the next command in my build script is make-j nproc, just like that. And what this does, make, will start the compilation process. I'm using GCC. The -j option tells you how many jobs you want to give to the make command. And nproc returns the number of processors that are on your computer. So when you wrap it in a dollar with the brackets, it returns the variable. That's the number of processor cores you have on your system, and tells the make command that you're going to use all of the processors you have on your system. Okay, so the next command in the script is make modules, which builds all of the kernel modules you have selected. It puts them into a unique directory for this kernel called libmodules kernel name, where kernel name is what you get when you type uname-a cut -d -f3, which is this kernel. So when you put it all together, like that, it gives you all of the kernels that are built for the current kernel that I'm running now. Okay, so the next command in the script is make modules install, and it installs the modules in the kernel directory given by the command you saw before, that, and it's the name of the kernel you are building. This keeps modules for each kernel separate from each other. You will also notice after building modules, the system creates checksums for each loadable module. This is a security feature. You can't use modules from one kernel version with another kernel version. The last line in the build script is update-initramfs. This is a script that manages your initial RAM disk file system. It keeps track of existing archives in the /boot directory. There are 3 options you can give to this script: create, update, or delete. I use the command exactly as you see it. What happens with the initial RAM disk is when your system first boots, the bootloader finds a kernel to boot and then unpacks the kernel image into a RAM disk, then mounts and uses it as an initial root file system. If you are rebuilding an already existing kernel, you don't need to run this, but if you are building a new kernel, you do. Okay, so the last thing I'm going to do is actually build the kernel. I'm in the source directory. So I'll go into Linux and run the script. And I'm going to load up one of my saved configurations. And you'll notice in the upper right hand corner of the screen, it's right now set to config, so this is going to change. And it's changed to this now. And then I'm going to save it to .config, and I'm just going to exit and it'll start to run. And now it's going to start to build and continue on with the script. I'm going to be back in a little bit and it will continue on. I'll just let it sit and run. Okay, and that ends our kernel build. We'll just check the current kernel. And we'll reboot the system and see what the new kernel looks like. Okay, so this is after a reboot. The bootloader defaults to the new kernel, and when I type uname-a, it shows the new kernel right here. A few more items. In the last section during the kernel build, the video showed 1 minute. In reality, it took about 100 minutes. Also, for more information about the ls commands, you can type man, which is short for manual, followed by the ls command, and it will give you all kinds of information. You can also do this for any of the other commands that you see, and you can see what they do and all of the options for each command, what that particular command has. Okay, so this concludes the kernel build video. It might seem like quite a bit of information all at once, but if you do it in steps, it should be manageable. Thank you for watching. Thank you for watching this video. If you liked any part of it, please do me a favor and click on the like and subscribe buttons. It would help me a lot. And if you want to be notified of when my next video drops, click on the bell. Thank you again, and I'll see you in the next video.